This was not supposed to exist. When astronomers first mapped our solar system, they noticed something impossible. 8 planets, billions of miles apart, all moving in perfect harmony. On the same invisible sheet of glass, no collisions, no chaos. Just a cosmic ballet that's been running for 0.6 billion years. But here's what kept scientists up at night. Why? What invisible hand arranged them this way, and what they found next changes everything we thought we knew about how worlds are born. Welcome to the single most elegant mystery in our solar system. If you've ever seen a diagram of the planets, you've probably noticed it. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, they all orbit the Sun in nearly the same flat plane. Like vinyl records spinning on the same turntable, this isn't an accident, it's a fossil. A 4.6 billion year old crime scene that tells the story of how our entire solar system was born. By the end of this documentary, you'll understand why gravity doesn't create spheres of orbiting planets, but disks, why spinning clouds collapse into pancakes, and why the rare exceptions to this rule reveal the most violent moments in planetary history. This is the story of the ecliptic planet, how it became the blueprint for every solar system in the galaxy. Before we understood how solar systems form, astronomers had a problem. Isaac Newton gave us gravity. He explained why planets orbit. But he couldn't explain why they all orbit the same way in the same direction, on the same plane. Think of it like this. Imagine throwing 8 frisbees into the air at random. What are the odds they'd all land spinning in the same direction, at the same angle? Statistically impossible. For centuries, this flat arrangement seemed like divine design. Too perfect to be random, too organized to be natural. Then in the 1700s, a German philosopher named Immanuel Kant proposed something radical. What if the solar system wasn't built piece by piece, but all at once? He imagined a giant cloud of gas and dust, a nebula that collapsed under its own gravity and spun itself into a disk, like pizza dough twirling in the air. It was brilliant, it was elegant, but it was also just a theory. For the next 200 years, scientists had no way to see this process happening. No telescopes powerful enough, no proof, until Hubble changed everything. In 1995, the Hubble Space Telescope turned its lens toward a region of space called the Orion Nebula stellar nursery, where baby stars are born, and what it saw stopped astronomers cold. Surrounding these newborn stars were disks. Flat, rotating disks of gas and dust, exactly like Kant had imagined 250 years earlier. They called them protoplanetary disks, and they were everywhere. Dr. Robert Odell, the lead astronomer, later said, "At first, we assumed it was an error. The images were too clean, too perfect. We thought maybe it was a glitch in the optics, but it wasn't a glitch." What Hubble revealed was a cosmic assembly line, stars forming from collapsing gas clouds. And around them, disks, hundreds of them spinning in perfect flatness. This was the smoking gun. Proof that solar systems don't form randomly, they form from rotation. Here's how it works. A cloud of gas and dust floats in space. It's massive, maybe a light year across, cold, dark, almost motionless. Then something triggers it, a nearby supernova, a shockwave. Gravity starts pulling the cloud inward. But here's the key, the cloud is already rotating. Ever so slightly, maybe from the motion of the galaxy itself. And as it collapses, that rotation speeds up like an ice skater pulling in their arms during a spin. Physics has a name for this: conservation of angular momentum. The smaller it gets, the faster it spins. But gravity pulls inward equally from all directions. So the cloud doesn't collapse into a ball. It collapses into a disk because spinning matter naturally flattens out perpendicular to its axis of rotation. The center becomes the sun, the disk becomes the planets. And that disk, that's the ecliptic plane. But here's the problem. If this theory was true, if all planets formed from a spinning disk, then every planet should orbit in the same plane. No exceptions, and for a while, that seemed to check out. Mercury, Venus, Earth, Mars all within a few degrees of the ecliptic. Then we got to Uranus. Uranus doesn't just orbit in the ecliptic plane, it rolls through it. The planet is tilted 98 degrees on its side like a bowling ball rolling down a lane instead of spinning upright. Scientists were baffled. Did this mean the disk theory was wrong? Some argued yes. Maybe planets didn't all form from one disk. Maybe they formed independently in random orbits and just happened to settle into a plane over time, but the math didn't support that. Simulations showed that random orbits would create chaos collisions, ejections, instability. Not the stable, orderly system we see today. So what happened to Uranus? At first, no one knew. The data didn't fit. The models broke down. Then, in 2011, scientists ran a new simulation. One that included something they'd ignored before: giant impacts. What if early in the solar system's history, a planet-sized object slammed into Uranus? The simulation showed it was possible, a collision massive enough to knock Uranus onto its side but not destroy it. Suddenly, Uranus wasn't a contradiction, it was a scar. Evidence of the chaos that followed the disk's formation. The same thing happened to Earth. Around 4.5 billion years ago, a Mars-sized object called the smashed into our planet. The debris from that collision became the moon, the disk theory held. But it revealed something else. The early solar system wasn't peaceful, it was a battlefield. The final proof came from an unexpected place: exoplanets. In 2009, NASA launched the Kepler Space Telescope. Its mission: find planets orbiting other stars. And it found thousands, but here's what stunned scientists. Almost all of those planets, gas giants, rocky worlds, super-Earths orbited in the same plane around their stars. System after system, disk after disk. The pattern was undeniable. This wasn't just how our solar system formed. This was how all solar systems form. Dr. Natalie Bataya, a Kepler mission scientist, put it this way: we went looking for diversity. What we found was a blueprint, and then came ALMA, the Atacama Large Millimeter Array in Chile, the most powerful radio telescope ever built. In 2014, ALMA captured the most detailed image ever of a protoplanetary disk. Not an artist's rendering, not a simulation, a photograph. The star was HL Tauri, 450 light-years away. And surrounding it was a disk so perfect, so geometrically precise, you could see the gaps where planets were already forming. This was it, the proof. We were watching solar systems being born in real time. The disk theory wasn't just correct, it was universal. Every solar system in the galaxy starts the same way. A cloud collapses, spins, flattens, and births worlds in a plane. But not everyone was convinced. Some scientists argued that what we were seeing in other systems didn't fully explain our system. Yes, planets form in disks. But why are the inner planets so small and rocky, while the outer planets are massive and gaseous? Why does the disk stop at Neptune? What happened to the material beyond? One theory: the solar system used to have more planets, giant worlds that formed beyond Neptune and rejected into interstellar space. Computer simulations by the nice model named after the French city showed that the outer planets didn't always orbit where they are now. Jupiter, Saturn, Uranus, and Neptune migrated inward and outward over millions of years like bumper cars reshuffling their positions. This migration could have kicked out entire planets, sent them tumbling into the void. Some scientists called it a revolution in planetary science, others called it speculative fiction. The evidence circumstantial: the asteroid belt, the Kuiper belt, the strange resonances between Jupiter and Saturn. All consistent with migration, but not proof. And then there's the biggest controversy of all: dark matter. In 2018, a team of physicists proposed that dark matter, invisible, undetectable matter that makes up 85% of the universe, might have played a role in disk formation. What if dark matter halos influence how gas clouds collapsed? What if the flatness of planetary systems is partially shaped by forces we can't even see? The idea is radical and testable and deeply unsettling. Because if it's true, it means we still don't fully understand how we got here. So here's what we know. For 0.6 billion years ago, a cloud of gas and dust collapsed. It spun, it flattened, and from that disk, our solar system was born. The ecliptic plane isn't just an invisible line in space. It's a memory, a blueprint frozen in time. Every planet, every asteroid, every comet, they all carry the fingerprint of that original disk. And when we look out into the galaxy and see the same pattern repeating, thousands of stars, thousands of disks, thousands of worlds forming in perfect flatness, we realize something profound. We're not unique. We're part of a process, a cosmic machine that's been running for 13 billion years, turning clouds into stars and stars into worlds. But here's what keeps me up at night. If every solar system starts as a disk, then every solar system has a plane. A narrow band where rocky planets form, where liquid water can exist, where life, if it exists, would most likely emerge. We've been searching the stars for decades, listening, watching, waiting for a signal. But maybe we've been looking in the wrong place. Because if civilizations arise in the ecliptic plane, then we're all neighbors on the same cosmic street. And the question isn't if we'll find them, it's when. If this discovery shocked you, wait until you hear what we found next. Because the ecliptic plane, it's just the beginning. In the next episode, we're diving into the exceptions, the rogue planets that broke free, the exoplanets that orbit backwards, and the one object in our solar system that defies every rule we just talked about. Subscribe now, you won't want to miss it. And drop a comment. Do you think life elsewhere in the galaxy formed the same way we did? Or are we searching for something we'll never recognize? Let's find out together.